Hello everyone. In this presentation, we are going to explain about the research report of the India's COVID-19 forecast using a cooperative analysis of machine learning models. Here in this presentation, we are going to explain about the machine learning models that we have researched in 2 to 3 research papers, and we'll also find the result and the summary of that. When it goes to the contents, we are going to explain about the abstract introduction, material and the method, and the results and the discussion. What is the data set that we have used, and the evaluation parameters like R2, mean parameters, and the results and the conclusion, and then the references that we have used for this research report. When it comes to the abstract, we all know that COVID-19 has faced a unique challenges in managing the pandemic, utilizing a multitude of data sources and machine learning techniques. And our main aim is to provide a comprehensive analysis of this situation. By beginning that, we are going to examine the age groups where most of the people are affected by the virus, employing various machine learning algorithms like SVM algorithm and the random forest and KNN and so on. And notably, the random forest algorithm emerges as a standout performer in both the regression and the classification task. Overall, we can say that, and the outshining other algorithms such as SVM, KNN, decision trees, and more. And the predictive model developed offers insights into the impacted rate, daily new cases, and daily total completed cases, which have shedded the light of pandemic tragedy. Furthermore, we conduct a multi-class classification analysis for COVID-19 cases in different states of India that focuses mainly on the confirmed death rates and the queued cases. Here we are going through the data cleansing, feature selection, and the K-cross validation. We ensure the robustness of our random forest model. And we can also consistently outperform other methods also. Our research here provides a holistic understanding of COVID-19 in India, contributing the global knowledge in the health crisis. When it comes to the introduction, as we all know how the COVID-19 has started, and in the COVID-19 cases resolved without the need for medical intervention, and the virus, the young people with all diseases like cardiovascular disease, obesity, or diabetes. And here we can also see that in the year of 2020, May 11th, India has reported like 67,161 confirmed COVID-19 cases. And these are the death rates and also the total cases. The machine learning algorithms which rely on data-driven models rather than explicit programming offer a valuable approach to understanding and predicting COVID-19 trends. The study mainly evaluates various regression models, including least absolute shrinkage and selection operator, that is called lasso, the decision tree, linear regression, random forest, and the polynomial regression using data obtained from covid19.organization.com. When it comes to the material and the method, like supervised machine learning model, in this study, we are going to forecast the COVID-19 cases. These models are trained on a labeled data set that will be seen ahead in this presentation, where each data point is associated with the correct number, like the answer, where the goal is to learn from these labeled data and make predictions on new unlabeled data. The 6 regression models are utilized in this analysis to forecast COVID-19 cases. One is the lasso. We can see here the statistical regression analysis tool, which is not only enhancing the prediction accuracy, but also performing attribute selection and validation. It was originally designed for a linear regression, but it can also be used for other type of regression analysis. These all information that we have gained, like we have summarized from the papers like IEEE papers that will be seen in the references. This attribute selection property can lead to more interpredictable models and the improved accuracy. When it comes to the support vector machine algorithm, this is used for the regression task. It works by transforming the input data into a high dimensional feature space using a nonlinear transformation, making it suitable for handling all the nonlinear regression problems. The main SVM algorithm goal is to find a decision function that fits the data while maximizing the margin between the different classes. It also performs nonlinear regression by transforming the data input into high decision feature space using the kernel function, as we can see the definition here, where the y dash is the distance from the value and the beta represents the slope or the gradient function, c is the value of x, and where y is 0. The goal is to find the parameters like beta and c that minimize the prediction value, that we will see in the further results and the discussion. When it comes to the decision tree regressor, here we can see basically the decision tree. We are classifying the data into 71 patients according to our study for the COVID-19, like 71 patients and 89 patients. And then these 71 patients are classified into 60 and 11. And then these 60 are classified into 39 and 21. Here we can see all the greater than and lesser than values of the results. Here the decision tree is basically the classification of the predicted values. These are effective for classifying and capturing nonlinear relationships in the data. These decision trees work to predict the number of patients by participating the dataset into subsets based on various features such as demographics, testing data, and local conditions. It's basically a tree-like structure where each branches represents a different combination of factors, as we can see in this picture. When it comes to the linear regression, it is a fundamental statistical method that is used in the machine learning, which establishes a linear relationship between the independent variables, as we can see here, the theta1 and the theta2, and the dependent variables. The goal is to find the coefficients that minimize the error between the predicted and the actual values. The linear regression is commonly used for a predicted numerical values. Our main goal is to find the theta1 and the theta2 that minimize the error term, which provide the best fit for the regression line. In this case, the total number of data points is indicated by n, and the h is the cost function of linear regression in the root mean square between the predicted value and the real value, that will be seen in the results and the discussion section. When it comes to the random forest, it is a learning algorithm that combines the multiple decision trees to improve the predictive accuracy of our research for the COVID-19. It works by training multiple decision trees on various subsets of data and averaging their predictions. This technique offers results in more robustness and accurate predictions because it has the risk of overfitting and the accounts for the complexity and uncertainty. By averaging these predictions for multiple trees, random forest has proven that it has the more robust and the accurate forecast considering the various factors. In this research, we have also analyzed that this algorithm is having the more robustness and the accuracy when compared to other algorithms, which is critical in informing health measures, resource allocations, and also in managing the COVID-19 crisis in India. And when it comes to the polynomial regression, it is a regression algorithm that models the relationship between the independent and dependent variables in the nth degree polynomial. And it also allows us to record nonlinear trends and the infection points, which help us to forecast more accuracy and comprehend how different treatments and outside influences might affect the pandemic tragedy. When it comes to the methodology, it has classified into like 5 steps. One is the data pre-processing, and then we are splitting that data into the training set and the testing set. And then we are training the model with these several algorithms. After that, we are evaluating the results like the R2 score we are evaluating, and also the mean absolute error, the root mean square error, and the mean square error, and also the result and the analysis. This figure illustrates the proposed flow of the study that we are going to discuss for the study of COVID-19. Here we can see we have taken the COVID-19 data, and then we are pre-processing it, and then we are data splitting it based on the models like Lasso, SVM, decision tree, random forest. All these models summary that we have taken from 2 or 3 research papers that will be seen in the references. And also we are evaluating these parameters, the 4 which will be seen in the results. These are the results, like the data set that we have taken. One is the observation date, the time, the state, the confirmed Indian national, and also the foreign national. This data set includes the illness of MERS and the SARS. In 2019, the COVID virus has mostly found causes illness that we can see here. The data set that we have taken from the Kaggle. When it comes to the evaluation parameters, we are evaluating the R squared score. Here we can see R square is equals to variance of the model by total variance. This is used to measure the strength of the relationship between the dependent variable and the regression model. It provides a value between 0 and 1, where the 0 means the model does not explain any variation in the dependent variable, and 1 means that the model explains all the variation. R2 is defined as the percentage that the independent variables account for in explaining the variance in dependent variable. It facilitates the evaluation of the model for the perfect fit. When it comes to the mean square error, it is the average square differences between the predicted values and the actual values. Because the lower MSE value suggests that the model's predictions are closer to the actual values, the main objective is to minimize the MES for this COVID-19 data so that the model data fits widely, which is used in penalizing the larger errors more heavily by squaring them. When it comes to the mean absolute error, this is the another measure of predicting the values, which is the average of the absolute differences between the actual and the predicted values. The objective of MAE is to minimize the error, like by concentrating on the average magnitude of the mistakes rather than their squares, because MAE evaluates all errors equally and doesn't penalize high errors. When it comes to the root mean square error, it is a standard deviation of the prediction error. These all results that we are going to see in the result section. Here we can see the results for the active cases. We have summarized these results from the research papers that we have made our summary through that. Here we can see the total results like R square, MSC, MAE, RMSE. From here, my friend Karthik will continue. Karthik?
Yes, can you go for the next slide, please?
Yes.
Yes, this is a result of graphs we are using and also showing the accuracy of results from the given research papers. You can see the range from 4,000 to the seconds, and these are the states we collect from the Maharashtra, Delhi, Rajasthan. These are states how much virus is spread over there. Next line, please. And these are one more graph results for active cases and prediction of using the couple of algorithms. These all algorithms are mainly done in this particular research is like they modeling the all algorithm give the best result for the active cases and uh, active cases and the deactivate cases like that. So these algorithms also help for mainly sure given the perfect result in that. So next slide, please, Rabia.
That have been from our research to other research papers where
Mhm.
it's totally different for the each research algorithm, like the random forest that we can see here.
Yes.
In this research we are going to display all the results for the actual and the active prediction cases that you can see in this graphs.
And here is a death rate forecasting I mean results. These are the actual models we are training in the research. We collected the research method. We collected the all stuff of modeling, like producing the linear regression and lasso and SVM support vector. These mainly underperform, but the models are evaluated like the accuracy, root square, and mean value, square errors, and mean value. This all shows the good accuracy in this particular research paper. So next slide, please, Rabia.
From this research we have also analyzed that the decision tree and the random
And random
forest has
forest are
proven the
provided.
best results, and
Yes.
even the lasso and the LR algorithm also produce the good results, but not as compared to the decision tree and the random forest.
And this is similar graph. This is similar graph to show up the all algorithms of active cases and the total death cases and the prediction by the uh, polylinear regression algorithms and also the models of how it's performing the exact value. And we can see the all type of graphs, how the scatter plot is shown in the graph of range. Next slide, please. Main coming about conclusion about this COVID-19 pandemic. We taken the two research papers in the COVID-19 pandemic topic. We accessed the and summarized all informed data from collecting the data set. So we training that data set and also search from the couple of papers and also give the predicted approaches of global level. So this data set contains historical data in May, month, year, and all formats also. Among all machine learning models we used in the machine learning models they used in this particular um, research papers, that it gives the best results for the end of the results. So like we can go for the forecasting active cases, death rates, and record those all ending with the best results, and also the polynomial regression and the lasso polynomial regression and also decision tree makes perfect and give the best results in the one of the best models in machine learning algorithms. And also it is evident that death rate and recovery rate will continue to increase upcoming days also indicated as forecast generated by the polynomial. So however, it's important to note that support vector SVM and also the favorable results primarily due to Here, we published they published the papers, and we collected the relative information and also provided the report as based on the requirement, like which models we have to use, like linear regression, machine learning model, and also uh, decision tree model, and also random forest model. These main four algorithms uh, perfectly train the model and gives the best result to the end of the research. We find that main, and also we summarize that coming to two research papers, we finalize that the best results is about we give a specific research to the provided report as the results for that exactly will be shown on the previously Stravi also explained about the all machine learning algorithms in that. So that's all from our end. Thank you, Professor.
From our analysis of this research, we have also analyzed that the lasso decision tree random forest also showed promising results in the forecasting of data. And it is also evident that the death rate and the recovery rate will continue to increase in the upcoming days of our data set. However, it is also important to note that the SVM is less favorable, providing us the less favorable results compared to other algorithms. These are the references that we have taken and also for our study. Thank you.
Thank you all. Thanks you once again.